Hey everyone. So in this particular video, we will try to verify the properties of linear convolution. Which are the properties of linear convolution, by the way? So three of them. Okay. So first one is the convolution. The linear convolution is commutative. What is meant by commutative? If at all you take some sequence x1 and convolve with x2, note the result. And if at all you take x2 and convolve with x1, both the things are going to yield you the same result. Okay, just like 1 plus 3 is going to yield you the result as 3 plus 1. Similarly, x1 convolved with x2 is going to yield you the result same as x2 convolved with x1, right? So is it a big deal, by the way? 1 3 multiplied by 7 is equal to 7 multiplied by 3, but 3 divided by 7 is not equal to 7 divided by 3. So the multiplication operator is commutative, whereas the division operator is not commutative. The addition operator may be commutative, but the subtraction operation is not commutative. That's why it's a big deal, okay, that the operator is commutative. So that's the first property. The convolution operator is commutative in nature. The second one is the distributive property. What does the distributive property say? If at all you have the situation where you are trying to add the individual operands, okay, then convolve the result. What you can do otherwise is you can individually convolve them and add the result. Both of them are going to give you the same thing. Wait a second, which one is a utility? Imagine a situation where you have to do two convolutions. Say x1 you have to convolve with x3 and you have to add it with x2 convolved with x3. You can see in this particular case you have to perform two convolution. Convolution is a very complicated operation, right? You need multiplication, shifting, and addition. X of k, h of n minus k. So complicated. Here you can see instead the same thing can be viewed equivalently as individual x1 and x2. First, then they are added, and then you get to convolve the result, and answer is going to be same. Is that a relief, by the way? Oh yes, it is, because two convolutions have been resulted in only one convolution. Okay, this usually applies in a situation where two systems are connected in parallel. Okay, two systems connected in parallel, three systems connected in parallel, four systems connected in parallel. So if at all you visualize the impulse response as a single impulse response, then the whole number of convolutions are going to reduce drastically. So that's the second property, the distributive property. And third one is an associative property. Now, what does this associative property say? If it also, this usually they call it as, systems connected in cascade, systems connected back to back. Then if at all say two systems are connected, three systems are connected back to back, then suppose the first two systems, if at all the resulting convolution of the equivalent response is going to be them convolved back to back. That means suppose x1 is convolved with x2 first, then you convolve with x3, and then you take single x1 only and you convolve with x2 convolved with x3. The answer is going to be same. Remember, imagine this particular situation. If at all you're trying to apply this thing to a modulus operator or a log operator, you can see it's not going to satisfy this particular property. Okay, so a convolution operator being associative is a big deal. So we are happy that convolution is satisfying these properties. Which one? The commutative, that means the interchange does not make any difference. Second one is associated distributive, that means individual impulse responses can be added, then you convolve. It's going to give the same result, which is, computationally, it can be very, very efficient. You can reduce the number of multiplications. Then afterwards, the associated, the cascade connection of the systems, okay, can be treated as individual convolutions are done in series. Okay, so these three properties. Now what we are trying to do here, we are trying to verify these particular properties. Okay, so already we have to verify these properties, so that's why I thought let's keep the thing simple. Three assumptions we'll make. Okay, so the not three. Okay, we will have a simple assumption that both the sequences or all three sequences that you are taking are going to be of you are going to start from zero. Okay, are going to start from zero. That's the only assumption. That's why we are not going to get into this thing, starting point of first sequence, starting point of second sequence, and all that particular thing. Okay. So let us keep this particular thing much simple here. Okay, so you can see here our program starts. So we need three sequences, you can see, for this particular thing. For commutative property we need only two sequences, but for associative and distributive we need three sequences. Okay. So let's get started. Okay, first let me have a clear all. Okay, it's better to have a clear all as my command, because there are so many previous operators are there in my workspace, so it's a clutter for me. And one CLC, so that my this screen is also clean. Okay, so let me execute those so that my workspace has become clean. Now you can see my workspace is clean. Now let us get started. Let me read the sequences, first, second, and third. I will keep it simple. Okay, so I will take from 1 to wait. Let me take some small numbers. Okay, so that the graph comes out neat and clean. Okay, so how many numbers? I will take three numbers only. So that's my first sequence. Then second sequence is 1, and third sequence is 4, 3. Okay, so I have read my three sequences. Now what I will do is, first I will convolve the first sequence with second sequence. Then I will convolve second with the first sequence. Okay, let us do it. I will name the convolution of x1 is, with x2 as x1, x2. Okay, so naming of variables is very important. Okay. So you can see here, we know how we do it. Okay. So I hope it makes sense. Okay, so here the individual convolution. So are you interested? By the way, you can see here my x1 convolved with x2 is 2, 10, 15, 10, 3. X2 convolved with x1 is also 2, 10, 15, 10, 3. There you can see it's verified, but then you have to display the things, right? So what I will do is, since there are three properties and two types of combinations, I have taken a subplot, which is 3 cross 2. That means 3 rows and 2 columns. So the first one and second one, let me use it for displaying this particular answers. Okay, so here what I will do is, I want my answer to start from 0. Let me make a slight change here. Okay, as I keep telling, in MATLAB always my result it starts from 1. That's, I do not want that. So let me have my x-axis starting from 0. So I will define my x-axis as starting from 0 colon till where it should go, length of the result minus 1. Okay, length of x1, x2. Okay, both are same anyway. Minus 1. Okay, length is 4. I should start from 0 and I to end at 3. So stem n comma x1, x2. Okay, and for the second one, stem n comma x2, x1. Now let me just plot these things. Let me just plot it. Okay, and you can see I will put legend also. What does the first graph stand for? What does the second graph stand for? Okay, let the legend display. And in I have 3 rows and 2 columns in the entire graph. So the first row, column 1 and column 2, they belong to commutative property. Okay, so here let me evaluate. And has the graph popped up? Wait a second, let me just show you what has happened to the graph by going to this share. Yeah, here. Okay, so now can you see the graph here? Can you see the graph? Not the second and the third one. Second and the third one are actually I used plot instead of stem. And second thing, you can see they are not starting from 0. Okay, we will correct it in time. I will correct it. Okay. So let us go back. Okay, one thing is for sure, you can see x1, x2, and x2, they're looking very similar, but looking similar is not sufficient. They should be, we should check it, right? So let's go to the program. Let us I'll go to the program now. Yeah, we are here. Okay, let us value this. So what we'll do is, for this particular thing, we'll use this particular comparison operator. You can see two equal to signs. If you can see looping. Okay, once again, if else statement. Okay, if x1 converted to x2 equal to x2 converted to x1, you can see this is not a normal assignment single equal to, this is 2. Okay, so if they are same, you can see here x1 and x2, x2, x1, they're looking very similar. If they are same, display that property is satisfied. Otherwise, display the property is not satisfied. No, let us say this. Yeah, you can see What did it return, by the way? Shall we try? Shall we try? Okay, let me just take this piece and let me just execute. You can see here 1 1 1 1 1. Okay, if they are same, it returns a logical one, otherwise 0. So since the array returned a complete, if returned a complete one, so it simply took it as property satisfied. You can see how we use this particular operator. Okay, so as I keep telling, we have two things to learn here. One is the convolution property. Second thing is MATLAB. Okay, the looping and all the things. Okay, so that was our first property. Now let us come to the second property, the distributive property. So in this particular property, what we'll do, let us have this particular thing first. So what we'll do, first we'll add the two sequences, first two sequences, x1 and x2. We'll call it as x1 plus x2. Okay, that's p stand for my plus. I have named it in some weird manner. Okay, you can also go ahead. Okay, okay. So first we'll add the first two sequences, and then we'll convolve it with the third one, right? That's what it says. Add first two sequences, convolve with the third one. Then what you do is convolve first with the third one, second with the third one, then you add. You can see convolve first with the third one, second with the third one, then you add the two, then you compare, then you compare. Okay, and here also, so then you compare. Where do you do this? Here you can see, if x1 plus x2 converted to x2 is same as the distributive. What is this distributive? Distributive is this thing where I did the x1 converted to x3 plus x2 converted with x3. If both are same, so did I execute this particular statement? Let me see. Wait. Okay, yeah, here I had not executed this particular piece. Okay, there I did. And now as far as plot is concerned, again here I have to make a small adjustment. Let me start my n is equal to where 0 colon length of my answer, which is both. Since I'm anticipating both to be same, I will take any one of these. Okay, I think this should be fine. Okay, so n only I have used. You can see n is going to change now. It's for the time it is 0 1 2 3 4. Now it is going to be different, I guess. Okay, depending on the scenario. I think it's fine. I do not need the previous n anymore. N comma, and here also for the second program n comma. Yeah. Now I think we are ready. Say let us some dogs bark here. Okay. Yeah. Okay. Now there is a situation. What happened? N is it is saying. Wait a second. Got some error there. Okay. So the error was because I had not subtracted one. And starting from 0, length of the sequence -1, because we are starting from 0, right? Okay. Now let's just run this thing once again. Okay. From here we start. Distributive property satisfied or not satisfied? Let us see. Okay, so distributive property satisfied with the equality. And similarly, shall we see the associative and we'll see the graph together? Okay, so now similarly for the associative property. So here in this particular property, what I have to do? First, I have to convolve x1 with x2, then convolve the result with x3. And in this case, x1 convolve x2 convolve with x3, then convolve the result with x1. You can see here, that's what I have done in case 3. Okay, convolve the x1 x2 with x3, because x1 convolved with x2 was already available for me. Okay, from the previous one, from the earlier property, again x2 x3 was also available for me from the previous property verification. That's why I have not done this thing once again. Okay, so and here also, in while I had got errors, I had stopped. I included this provision for n also here. Okay, so yeah, we are all set. The third property, the associative property, and the associative property also satisfied. Okay, so let me show you the graph now. Here we are. Okay, so you can see Let me make this graph a little bigger. Okay. You can see how important it is to put the legends. Okay. It is important. What does the figure 1 stand for? What does the figure 2 stand for? I had put a plot earlier. I think stem is better because the values are discrete values. Stem is also better. You can see what is it? The graph on the left looks similar to graph on the right. No, no, no. The graph on the left and graph on the right are giving exact same values. Hence the property is satisfied. Okay. Now, let me go back here. Okay. So I always feel that I'm misleading you guys with this thing. So the actual method is of running the program. The actual method of running the program is you go here in the editor. You go here in the editor. Wait a second. Wait a second. You go here in the editor. The best method is go to this particular command. If at all you want to debug and you want to check each and every step, then only you're going to select individual line and run. Otherwise, what you're going to simply go here to the editor, go so it's this particular green button with the run on it, and just click this particular thing. I think yes, there you can see it has popped up. Okay, so wait a second. Uh, okay, enter the first sequence. You can see, and now let us enter something different. Okay, the second sequence, third sequence. Okay, and then afterwards, we simply wait. Associative property satisfied. What about other properties? Distributive property satisfied, commutative property satisfied. Okay, so you can see the answers have been displayed there, and then afterwards, yeah, and it's always a good thing to display the answers. Okay, so what I will do is let me include that thing also in the program, that I should always display the answers. Okay, both the answers, because how otherwise how will you know? Okay, in the workspace you can always see them. And okay, so make the provision, make the change in the program. Now let me show you the graph also. Let me show you the graph also. Okay, for the associative, the commutative, and the distributive properties. Okay, so that was that. See the numbers. Okay, so the values are how different. See the different lengths for individual properties also. Okay, so that was that about the properties, verification of convolution properties. So how different is this program from the previous convolution program? There we wanted to learn the looping in MATLAB and all those things. We wanted to have fun. That's why we did not use the ready command. There we had the provision for starting point of the first sequence, second sequence. So all this here we have kept the program no nonsense. Okay, because we are interested in verification of properties. And yeah, we came to know how cleverly we use this particular if else statement here, right, for the verification, that double equal to thing. Okay, so overall not bad, I guess. Okay, so that's that. Okay, let me stop here.